Hello sir, I'm Ray. So I will walk you through my code and show you the results. I broke down my examination into 5 sections. In the first section, I will talk about classifying the MNIST datasets, which helps with understanding how to process images and optimize header parameters. And in this section, I will display the confusion matrix like this. Okay, let's move on to the next section. The next section is about the classified CIFAR10 image size. The first thing is import necessary libraries like TensorFlow, sklearn, very useful for us to do some machine learning, and load the data from the data size, names xchain, ychain, xtest, ytest, and we can view the details here. And then normalize all the data size except label. Very obviously, just use data size to divide them by 255, and then show the details and to show some pictures. I want to see some pictures, some example. So I print them below. And the next one is flatten the image into one-dimensional form. I use this method, reshape and flatten, to flatten the data set. Like the label is after flatten is like that, and the exchange shape after flatten is like that, has 15,000 pictures, and any pictures has 3,072 features. And at first I prepare to use those data sets before PCA to train and test, but I find that the result is too bad. It will spend a lot of time and we will get a bad result. So that is too low accuracy. So I decided to do a PCA to reduce some dimensions at first. So I import PCA from sklearn, and I set the parameter is 95%. That means just keep the 95% variance, and we can see the results here. Just keep around 200 features. That means a lot of features are useless. And section 3 is use the dataset after PCA to train and test. For example, the decision tree. The decision tree, I didn't set any parameters, and used the dataset after PCA, and I can train and test and predict, and I can get the accuracy like this, 0.2562. And the other 3 algorithms you use the same method to train and test with default parameters, and we can see the result. We can see different each result here. SVM is 0.5553. Bayes is like this, and KNN is like this. All of these are not too high, is not good result. That means we should optimization. We should find the best parameters to get the best models. Due to the performance limitation of the laptop, using the GradSearch-CV method for header parameters optimization takes a long time and has a very low efficiency. Therefore, I used a loop statement to perform manual optimization instead. You can see I didn't use grad search CV. I use this method myself. That means in this loop structure, I set different parameters here and use this loop structure to create different decision tree classifier with different parameters and use each classifier to use three cross validation to calculate the score and the accuracy, and we can get the print things here. The best CV accuracy is 0.3141. That means the best parameter is the max depth is 15 and the minimized simple sleeves is 45. And then I use those two best parameters, set them into a new classifiers like this, and the chain test again and predict and show the accuracy of the classifiers. That is 0.3212. It's better than the default. Classifier default parameters. And KNN and Bayes is the same. Use the same way. KNN is set different K, and Bayes is set different smoothing to search the best parameters and the best accuracy. And KNN, the best K is 3, and the best accuracy is like that. And the Bayes, the best thing is the best accuracy is like that. And after that I also put best parameter into a new classifier to retrain and retest and get a different accuracy. And obviously all of these are better than the default parameters. But especially I don't use the totally same ways to calculate to optimize the sport victor machines parameters. Due to the performance limitation of the laptop, using the grad CV, yes. And then in that case, SVM will spend a lot of time. Even those after PCA. So I decided to choose a part of chain site randomly to optimize to get the best parameters. This is the number of how many I choose randomly. Yes, very randomly. And this picture is show the class distribution of training data. You can see it's very balanced. So this data set can be used. And then do the same thing. Use the small sample. Use the small sample chain site to train and test with the default parameters, and I will get the default parameters accuracy is like that, 44%. And use the same way to search the best C, because the gamma equals scale is very stable, is very wonderful, so it cannot be changed. I can only change C's values here, and I input different C and create different classifier and calculate calculate themselves score and accuracy here. The best C is 10 and the accuracy is like this, but I don't think 10 is the best one. so I search carefully. So I search carefully around 10. And finally I can get the best C is 3 and the best accuracy is like that. It's better than the C equals 10. After that I can use C equals 3 into a new classifier and get the new results like this. Accuracy. The last section is evaluation. I use those four numbers and one pictures to show you the evaluation. Accuracy, processing, record F1 score, and confusion matrices for any different algorithms. For example, we can see the decision trees evaluation result. We can see the different values here, and we can see the confusion matrix pictures here very obviously. And we can see the different algorithms here. The different algorithms get the different results. The performance can be determined by the color of the diagonal line. The color of the diagonal line. The darker the color, the better the performance. So that means the SVM is the best. And the decision tree is the second best, because it's not too dark, but it's still dark. But for the Bayes and KN, it's very bad model. Yes, it's very bad. That means it's not suitable to deal with because these two algorithms is not suitable for dealing with the CIFAR10 image dataset. Okay, that's all. Thank you. Thank you for listening.